What's going on, everyone? My name is Liz from Learn Robotics. This is episode number 5. If you've missed any of the previous episodes of Learn Robotics Live, they're a lot of fun. This is the special topics free robotics course that you can take at your convenience. We air it every Friday at 12:30 p.m. Eastern Standard Time, but you can catch all of the replays in our free robotics course, learn at your own pace, download the code samples, and try out the projects for yourself. In today's episode, we've got a lot more tech, a lot more programming. We're going to be adding some features to our mini Jeeps. So if you haven't picked up the mini Jeep kit, I've left a link in the show notes below where you can go and purchase your own kit and try this project out for yourself. In the previous episode, we focused on connecting it to our Bluetooth app using either iOS or Android, and then driving it around using Teleop. And then we also explored how to create some simple programs using the built-in Scratch programmer. So if you've missed any of those episodes, head on over to learnrobotics.org, sign up for the free course, and re-watch episodes 3 and 4 of Learn Robotics Live. So in this class, we're going to be focusing specifically on how to program the L293D motor controller. This is a little bit different than the typical motor controller that I use in all of my courses, which is the L298N motor controller. But the principles of programming a motor controller are very similar regardless of what motor you're working with. So I'm going to walk you through the process of finding all the documents that you need, mapping them to the actual pins that you're going to be using to control your motors, and then we're going to write some simple programs and methods that can be reused to create some autonomous moves. So grab all your materials, get ready, it's going to be a lot of fun. I'll see you right after this short intro. Things about doing these videos is you just get to see my face. So if you've been waiting for the hardcore programming of this Learn Robotics Live, today's the episode. We're going to be diving into how to find the correct information for a motor controller and then using that information, deciphering the documentation to actually write code that works. And so this is an area that a lot of my students have struggled in because they don't know where the values are coming from, and it always goes back to the datasheet. So regardless of whatever robot you're using, the manufacturer should tell you what motor controller, what components are used in the circuit board. So the main motor controller used on this board is the L293D motor controller. So let's head on over to Google and we can search for the L293D motor controller. And so we want to find the datasheet. So typically if you just type in the name of the board plus datasheet and hit enter, you should be able to pull up the actual pinout diagrams, and you should be able to find the datasheet. So this PDF is what we're looking for, and the worst part about deciphering datasheets is that they are very technical. They include all of the engineering information about the chip or the component that you're using, and it can be challenging to figure out what you actually need to use to program it. And so what we're looking for is a truth table that defines bidirectional movement for our motor. So we want to be able to move our DC motors both in the forward direction and in the backwards direction. And because we have two sets of motors, we have one on the left side and one on the right side, we're going to want to be able to control both of them simultaneously and then move forward, backwards, left, and right. So let's go ahead and look through this data sheet. And typically what I'll do is I'll kind of try to find in the table of contents something that might be relevant. So we've got pin configuration and functions, so that might be useful. So this is just giving you a high-level overview of the pinout of this motor controller. So similarly to the Arduino has a bunch of pins that you can interface to. This motor chip also has pins you can interface to. And the Elegoo mini car kit has already connected all of these pins together for us. So what we can do is reference that diagram in a little bit to figure out where the pins are mapped to on the Arduino. But for now, we're just going to get a feel for how things are set up on this motor controller. And what I'm looking for as I just kind of scroll through here is I'm starting to look for modes or these truth tables that will define how the actual output will work when we provide it an input. So there are basically 3 pins for each of the motors. We've got an enable pin and then 2 input pins, and then a combination of all these pins will give us an output. And so what we want to find is a table where we've got bidirectional DC motor control. And so what we're going to use is this figure 10 bidirectional DC motor control. You can kind of see how this works. We've got ourselves a DC motor. It can go both forward and backwards, which is exactly what we want. And then what we can do is use this table 3 to figure out what functions do what. So if we set the enable to high or active, and then the first input to low and the second input to high, the motor will turn right. And then what we can do is set the enable to high, set the first input to high, set the second input to low, the motor will turn left. And then we've got a few different combinations here. So if they're both low or both high, it'll be a stopped condition. So what we'll do is we're going to translate this table from the L293D motor controller datasheet into code that can be read on the Arduino. And our little robot Jeep has a built-in Arduino Nano that we can program to actually talk to the motors. So let's go ahead and open up Arduino. And I've already got a sample sketch that I've written for this, but we'll go ahead and we will open up a second sketch here that we can work on together. And all of the code samples and documentation for this project will be located in the free robotics course. All you need to do is click a link either in the description below or above this video if you're watching on learnrobotics.org and sign up for the free robotics course and you'll gain access to all these downloads. So typically what I'll do is get started with this sketch. I'm just gonna kind of give it some information. It's just gonna control the motors for the robotic Jeep. And we've got basically just the L293D motor controller. So that's pretty good. And then what I typically like to do is figure out where the motors are connected on the circuit board. And so as I mentioned, we've got 6 different pins that are connected into the Arduino Nano, and the only way we're going to figure out where they're connected is by referencing the datasheet that the manufacturer provided. So if you open up the folder that I've included in today's lesson, you'll find a document that says make the mini car move, and in there you'll see the connections between the L293D circuit pins and the Nano. And so we've got basically this mapping right here. So we've got the first enable on D11 or digital pin 11. The second enable is on digital 10. And then we've got the first A on 7, the second A on 8, third A on 12, and fourth A on 4th. So we can use this to set up our code. And so if you're brand new to motor control, we're essentially just going to be sending it an enable signal and then a combination of highs or lows to determine the direction. And that pattern is determined by this truth table from the datasheet. So this has already been specified for us. We're just translating this information over to Arduino so that our robot can understand it. So it might seem like there's a lot of tables going on here, but I'm going to walk you through this process. And once you learn this process with this controller, you can repeat this process with all kinds of other controllers. And I'm going to leave a link in the show notes below on how to use the L298N motor controller with Arduino, because I use that very frequently in a lot of my robotics projects. It's a high voltage controller, so I think you can go up to like 46 volts on that controller. So if you've got something that needs that much power, it's kind of an interesting chip to use. But for today, we're going to be using the L293D motor controller, and I'm going to show you right now how to get that set up. So let's create some variables for the left side of the robot and the right side of the robot. So what we can do is just do a left enable, and that left enable is going to be on D11 using our table. And then we'll do the left 1A, and that is going to be on 7. And then we've got 2A, and that is going to be on 8. So now let's do the same for the right side. And that right enable is on 10. and then we've got write 1A. That is going to be on 12. And then we've got write 2A, and that's going to be on 4. And that's pretty much it. So it looks pretty good. So we're good with this connection diagram. Once you have your connections mapped over in code, we're all set with this. We don't really need to use this anymore. Now we're going to be focusing on the actual datasheet, because this is going to tell us the functionalities of what direction the motor is going to be moving in. So now we can head into our setup method, and we can just set all of these as outputs. So we'll just do a pin mode left in, and that's going to be an output. And pin mode left 1A, that's going to be an output. And this is a built-in method. You can refer to the documentation on the Arduino website on how pin mode works. It's just setting the pin as an output as opposed to an input, because the digital pins could be used either or. Pin mode left 2A, and then we'll do the same for the right side. I'm just going to make this a little quicker by doing a little copy paste, and we'll just update these. Okay. And what I typically want to do also is just set the serial monitor, because we can use this to debug our program. So the Nano has a baud rate of 9600 baud, so you can just add that in. And I'm just going to print out an initialization line that'll just tell us that we're initializing the serial monitor. All right. And then once we're initialized, I'm just going to write ready. All right. So the way setup works is once the Arduino turns on, it goes through this setup routine, runs it once, and then it jumps down to loop, and then it runs through loop top to bottom until it gets to the bottom, and then it runs back through continuously until you either tell it to stop. So you can consider it similar to like a main method if you've done some other programming. So now let's go ahead. I'm going to just do a quick little compile. I want to save this as the Jeep project and make sure everything's good, make sure I don't have any typos anywhere. And then I also want to point out that if you are using an older version of the Arduino IDE, you may have to go and update your Arduino Nano board manager. And this can take about a minute to do. So when you're in here, you just want to go under the Arduino AVR boards and make sure you have version 1.6.21 installed. If you have a version that's earlier than that, it will not send the code over to the actual robot. So just something to kind of be aware of. So basically what we've done so far is we've mapped the code to the actual wiring on our board. Now what we need to do is we need to tell the motors how to move. And so what we're going to do is create a series of smaller methods for each of the directions. So the first method I want to create is a forward method. And this is going to just drive the motors in the forward direction. And as I'm setting up these methods, typically what I'll do is I'll do a first pass through the method, think of something that is absolutely critical for the method to work, and then I'll go back and I'll tune it to add in some features that might make it more useful as I'm reusing code later. And so this is going to be the first pass. I'm basically just going to translate this table into the code. And so what we'll do is we're going to set a series of digital write commands, and these digital write commands will set that pin high or low to match our table. So the first one is we are going to do a digital write on the left enable so that it's high, right? Because we've got a requirement that the enable pin has to be high in order for any of this to be true. So we're going to do the left enable, and we'll do the right enable. And so now those are both active, so that's good. I'm just going to put a comment here that just says set enables to high. All right, and then what we can do is go through and start mapping these out. So what I want to do is do a digital write on the left side, left 1A, and I want to make that low. And then I also want to do a digital write on the left 2A and make that high. And so we've got this first line on the table mapped out. And because we have a second motor on the right side that's flipped in the opposite direction, I'm going to take an educated guess that if we flip the readings on this, we'll have something that goes forward. And we can test this out to make sure it's right. Write 1A, and that's going to be high. Digital write 2A, and that's going to be low. And that looks pretty good. So now basically what we have is a method that will drive the robot forward. We can test this out by calling it in loop and compiling it. And then what we need to do is upload it to our robot. So I've got the robot right here. All we need to do is plug it in via USB. And then on the side, you want to make sure that the switch is pointed on either the D or the U setting. D for download, U for upload. It depends on which version of this that you have, but just make sure it's on the D as in dog or U as in umbrella setting, and then you'll be good to go. And you're plugging it into the download port. So grab that USB cable, and then we'll go up to make sure we've got the Arduino Nano selected as the board. And then processor, you can just leave that alone. And then we've got this USB modem 00001. And then you can just go ahead and click upload. It'll go through, it'll do the upload process. And what we should see is the motors are actually running right now because we set it to the forward method. And if all goes well, you'll be able to use this as a starting point for making some updates. And so as we're running this, we can go ahead and run this on the ground. I'm going to show you what actually happened, and if this happens to you, how to fix this. So what we can actually do is we can take our robot and then run a quick little test on the ground. Just place it down here, turn it on, and you'll actually see that it's moving out of frame because we've set the direction backwards. And so what that means is we can head on over to our computer, and the actual sets of inputs are correct, but their directions are wrong. So we can just flip these, low, high, and then go ahead and do a quick little upload. Send that over. And I highly recommend running these little mini tests just to make sure that your educated guesses are actually correct. So now that we're uploaded, I'm going to send it over to our testing area. And we can go ahead and put it on the ground. And you'll see our robot is now moving forward. So now that we've solved the problem of having the robot move forward, what we need to do is tell it to stop. And so that's the next bit of code we're going to need to write. So our forward method works great. Now the next method we need to do is stop the motors. So we can just create a method called stop motors. And for that, we are going to set them, we'll set everything to low. How about that? So I'm just going to go ahead and copy this. And we're just going to update everything to a low condition. And then what I also want to do is I want to create another method that's just an intermediary method called enable motors. And this is just so that I don't have to keep writing this enable or disable code over and over again. I can just call the enable motors. And so this is going to set the motors to high. What I also want to do, I I want to give it a condition where if it's true, it's going to be active. If it's false, it's going to be inactive. So what I'm just going to do is call it active. And basically, if active, we can set this to high. Otherwise, we're going to just set it to low so that the motors are disabled. It's just good practice to have control of your motors and be able to enable and disable them easily. In a situation like this, where it's just a little hobby robot, it may not seem as critical, but just something to consider as you're gaining skills in robotics. I'm going to actually just, for semantics, update that. Okay, make sure I've got all my curly braces. And now what we can do is we can just call enable motors, and they are enabled, which is good. And then what we can do is we can go ahead and just disable the motors by calling it false. And just throw in a couple of comments in here so that as I look at this later, or as you're reviewing this document, you'll be able to understand what's going on. So now we've got a method that enables the motors, disables the motors, a method that moves the motors forward, and a method that stops the motors. And so what I want to do is I want to create a method, or create a program rather, that drives the robot forward for a second and then stops the robot. Very simple program. And so what I want to do is call the stop motors. And let's go ahead and test this out and see what happens. So let's go ahead, let's add in like a 1 second delay like I had mentioned. And now let's go ahead and test this out. We're going to see what happens, and then we're going to make some adjustments as needed. Okay, go ahead and give this a little upload. All right, we're good. Take this out. And what we're going to do is head over to our test area. And I always recommend testing this on the ground. It just makes this so much easier. Most tables aren't large enough to be testing these robots, and you don't want to shoot it off the table by accident. So what we want is for this to go forward and then stop. So it didn't work. Weird, right? So we told the robot to go forward and we told the motors to stop, but it didn't stop. And so what we want to do is try to figure out why that's the case. And so the way loop works is it goes through the first method. So it's going to read this forward. It finds forward in the list, reads through forward, finishes forward, then it goes back, does its 1 second delay. Then it's going to find stop motors, goes through stop motors, goes through, and then it actually goes back to the beginning, and it keeps going over and over and over again. So to overcome this, what we're going to do is we're going to create ourselves a variable to keep track of our loop. And so I'm going to create a Boolean called isRunning, and I'm going to set that initially to false. And we can enable isRunning in the setup. And then what we can do is throw ourselves in a nice little while loop. And so then while we are running, we can go forward, wait for a second, and then we can set isRunning to false, and then we'll end up jumping out of the loop and stopping our motors. So now what we can do is we can upload this code to the robot and test it out. All right, so we are done uploading. Take this guy and head over to our little testing area and place it on the ground. And what we should see is that the robot will drive forward for a second and then stop. Boom. Cool. Try it again. Cool. So now we have the basics of motor control. The next step is to create methods to drive the robot left and right, and then also control the speed. Now I am testing on carpet right now, so speed control is going to be very minimal. I'm probably going about half speed as I usually would on tile or like a hardwood floor. but I'm gonna show you how to do the speed control because why not? That's what this is. We're gonna have some fun here, right? So let's head over to the computer, and what we can do is, because our enable pins are plugged into PWM pins on the Arduino Nano, we can actually send an 8-bit signal to the enable pin to set the speed. So let's go ahead and create ourselves a little method called speed control. And that's going to take in a left speed and a right speed. And these are going to be based on an 8-bit number. So that's going to be a range of 0 to 255. So that's 8-bit. And what we can do is we can just do an analog right to the, let's see, left enable. And we're going to use the left speed. We can do another analog right to the right enable pin, and that's going to be the right speed. And now when we send it a value we call speed control left speed, right speed, we can do half speed, we can do quarter speed, we can do 75% speed, we can do all kinds of speeds. And that'll enable us to move at whatever rate we want to with our little robot. So what I'm going to do is I'm going to do a speed control, and we'll do a full speed. So the reason why we have two different motor speeds is so that you can compensate if one is a little bit more powerful than the other. So if you notice as you're running in the forward direction that you're moving left or right, you can bump up the one that it's lagging in so that it evens out and you get a nice straight direction. So now we've got our speed control added in there. We can go ahead and compile it. Like I said, I'm not going to show you how this works because I'm testing on carpet and there's very little difference in speed. I've got this running at full speed now and it looks about half speed just based on me running it on tile. But that's how you add in some speed control. The next step is to create some motor control for the direction, so turning. And what you can do is just create a method called left. And then you can create a method called right. And then what you'll end up doing is sending over some commands. So let's go ahead and take a look at this. So if we want to make a left turn, we want the left side to go backwards and the right side to go forward. And so basically that's the high level overview of what a turn is. You're sending one set of motors in reverse and the other set of motors straight ahead. And so we've already got the left side going forward. So we just need to flip this so that they go backwards. And then the right side is already going forward. So that's going to give us our left turn. And then our right side is going to be the opposite of this. So what we can do is just go ahead and make this a high, low. And then a high, low. So now we've got these methods that will enable us to turn in either direction. So let's go ahead and test this out. So I'm going to just comment out this speed control. I'm going to test out the we'll do a right turn for a second, and then we'll do a left turn for a second. Okay, let me grab the robot. Go ahead and plug this guy in and send it some code. Cool. All right, so it looks like it's working. So I'll just set it up. So it should go right and then left. And remember, this is the front of the robot, so shut this off. So right turn, left turn. Pretty good, pretty good. That looks really good. Okay, So you can play around with this. Obviously, your turning amount of duration and whatnot, you can always convert that over into some sort of an angle or whatever it is you're trying to do with your robot. If you're doing some sort of autonomous move or you're trying to navigate a space, you can adjust that and fine tune it. But that's basically it. I mean, we took a datasheet, which is a lot of engineering jargon from Texas Instruments. So you can thank the engineers over there for creating that table. All we did is we took the bidirectional DC motor control patterns, moved that truth table over, we mapped our pins, we mapped the actual configuration of the motor controller, and then we ran some tests, and then we just iterated on that to add in some speed control, add in some directions, and control this robot. So now the challenge is to use these functions, go out there, learn how to make your robot navigate all kinds of shapes, maybe take some tape, map out a square, map out some patterns, and try to move your robot autonomously across those patterns. Practice it. It takes a lot of skill. If you didn't understand what was going on here, feel free to sign up for the free robotics course. Watch the replay of this video. It is confusing. I will leave some links to some more resources about this topic in the show notes below. And if you have any questions at all, feel free to comment on this video, find me on social media at Learn Robotics, and I hope you guys are having an awesome Friday. It's been a lot of fun working on this robotic Jeep. Next week, we're going to be taking a look at sensors, potentially integrating some sensors onto our mini Jeep. But until then, have an awesome weekend. Thanks for checking out Learn Robotics Live. If you have a friend that's interested in this content, be sure to share it with them. It's 100% free. It's a lot of fun. You know, it's kind of like Netflix for nerds. And I will see you next week on Learn Robotics Live. See you guys.